Welcome back. Today we are going to learn about the devices. Last lecture I spoke about PN junction diode. It's all these devices are made up of this PN junction diode, the application of PN junction diode. The first one is LED. LED stands for light emitting diode. Light emitting diode means it's a diode which can emit light. So it's a semiconductor diode, just like your PN junction. The symbol remains same, but we have these two arrows that represents the light which is coming out of this. How does it happen? When light emitting diode is forward bias, so it's a forward biasing device, where the minority carriers flows large number into the region where they can recombine with the majority charge carrier to produce light. Like here, the wavelength of the light, whatever is produced, is proportional to the band gap. If you somehow make the band gap, and which is, if you take the wavelength corresponding to that energy falls in the visible region, then you have a LED with you. So what you do is like when you apply strong electric field, the holes from this jump to the electron, they combine with the electron in the cathode, and when the holes and electron combination happens, there is a release of photon. If it happens to be in the visible spectra, we have a light. And this is also known as injection illumination. Means you have excess, you just force the electrons to combine together, and they produce light. So that's what injection electroluminescence. So this is a typical diode. If you have seen the diode, so it has a anode and it's a cathode, and this is where the semiconductor lies. And the top one, whatever you see, it's a epoxy just to protect it. Okay. So how does it work? Usually they make it through deposition technique, like layer by layer deposition. First you deposit n-type material, then you have some active region where the electron from n-type and holes from p-type and combine, and they produce photon. So then you have a p-type region. So you deposit these regions, and you connect negative terminal to this and positive terminal to this, so that the electron holes will move from here and electrons will move from here, and recombination happens, and that's how they produce electricity. So if you look at the schematic or the band structure, what will happen is the Fermi level for p-type will be near the valency band, and n-type will be near the conduction band. So when you combine them, it will look like this. So when you give energy to the electron, they will move to the p-type region, then the holes will move to the n-type region, and there you have a recombination of electron and hole happens. This will give the rise to energy, and if this energy falls in the region of your visible spectra, then you have a LED, or the light emitted from the diode. So there are the various materials that you use, like for example the red or the infrared, what you use in your remotes and all. For that you use gallium arsenide. Then gallium nitride is used to bright blue light. If you see the blue LED, then it's a gallium nitride. Yttrium aluminium garnet, that is for white light. Gallium phosphate for various lights based on the composition. You can have aluminium gallium nitride, ultraviolet light, aluminium gallium phosphate to emit green light. So these are all different kinds of material that you use. The idea is simple, just you have to see the energy gap which is equivalent to the corresponding wavelength of the light. If you can engineer the band gap by adding various elements, then you get the color. And now this is a direct band gap semiconductor, because whatever the band gap is, that much energy is emitted in the form of light. There is no heat or no secondary emission that is happening. But where do you use it? You have lot of applications like your laser. LED laser is one of the applications. Bulgar, the alarm systems, calculators, mm, phones, traffic signal, digital computer, multimeters, microprocessors, digital watches, automobiles, camera, flash, aviation industry. Wherever you talk about, you use it. Now, because this is a very like cost effective, and also this is also used as a sensor, like how much light it can produce based on how much potential you are giving and how much energy you are giving. So it can use as a photo sensors also. So this is all about your LEDs. They have two types also, visible and invisible LEDs. Your whatever you use in your remote control is an invisible LED or the infrared type, or ultraviolet also. Beyond that also you can have. So this is called invisible LED, and all visible LEDs are your whatever you use for the light. So that is one of the application of your diodes. In the next video I'll talk about the photodiode as well as your solar cells, because they both more or less